So this is 2005, number 4. And basically some boxes of a certain brand of breakfast cereal include a voucher for free video rental inside the box. The company that makes the cereal claims that a voucher can be found in 20% of the boxes. Okay, so however, based on their experiences eating the cereal at home, a group of students believes that the proportion of boxes is less than 0.2. So this group of students purchased 65 boxes of cereal to investigate the company's claim whether or not there was actually 20% that contained a free video rental. Now, we are dating ourselves with the video rental context, but let's bear with it. Let's just bear with this. The students found a total of 11 vouchers for free video rentals inside the 65 boxes. Suppose it's reasonable to assume that the 65 boxes purchased by the students are a random sample of all boxes of this cereal. Based on this sample, is there support for the students' belief that the proportion of boxes is less than 0.2? Provide statistical evidence to support your answer. So the first thing I'm thinking when I see this problem is that I've got 11 out of 65. And I want to know, is that proportion truly less than? It's very clear that it says in there they believe it's less than, okay? So they don't believe it's true, okay? And here is where they say they believe it's less than. So this immediately says to me that this is a hypothesis test, and we're going to do a one proportion z-test, okay? And when we are doing a null or a one proportion z-test, automatically I'm going to go to my 4 quadrants. So the first thing I'm going to do is in the upper left, I'm going to write my the name of the test, and that's a one proportion z-test, and then I'm going to write my null and alternative hypothesis. Now remember, in the null and alternative hypothesis, the null hypothesis is the statement of what has been set as the established standard. In other words, the statement of no effect. And in this case, the true proportion of cereal boxes containing vouchers is 0.2. So the true proportion, and that is of boxes containing vouchers is 0.2. Okay, and that is P equals 0.2. Okay, and that represents P sub 0, which is P naught, our null hypothesis value. Our alternative is the true proportion of boxes containing vouchers is less than 0.2. And that is P is less than 0.2. Now over here on the right side, we're going to write our assumptions and conditions, okay? And to write our assumptions and conditions, to do that, we're going to remember our IRS 10, independent, random, and our sample size, and our 10% condition. So if you want to pause the video and write your conditions, go ahead. I'm going to go ahead and do that too. Okay, so we assume that the boxes are independent of each other, and it is given that randomness is assumed, and there are 11 boxes with the voucher and 54 without. Both are greater than 10. That satisfies our NP/NQ greater than 10, and then 65 is certainly less than 10% of all cereal boxes. So that satisfies the conditions. Therefore, we will proceed with our test. So I'm going to have you pause the video and write down kind of everything you know in the lower left corner for calculations. So this will be the calculations right here. And we're going to calculate our test statistic and p-value. So you'll see that I've got the calculations here, and I've P hat is 11 out of 65. Our P naught is 0.2. Our standard deviation of P hat is the square root of P naught Q naught over N. Remember, we're using the sampling distribution based on the null. And remember, when we calculate a p-value, we are assuming that our null hypothesis, okay, we're assuming that our null hypothesis is true. And if we assume our null hypothesis is true, we need to use this as a standard deviation for p hat, okay? So we're using our null hypothesis, P naught Q naught over N. So given that I've shown all these values, I think this is good enough. Now we want to calculate the probability that Z is less than negative 0.6202. So the probability that Z is less than negative 0.6202 is equal to 0.2676. You'll notice that I've drawn a sketch of the normal curve with the Z, the p-value shaded, and always label my normal curves. Whenever I draw a normal curve, I better put my, this is a standard normal curve, then I'm going to put n 0, 1 here. If this is a regular normal curve, then I will, you know, if I put whatever the mean and standard deviation is, if I'm using that. Now the time has come for us to make a conclusion. So remember, when we're discussing a p-value, we are looking to see, are we surprised by this value? Is this value making us say, you know, hashtag OMG? You know, are we looking at this thing and are we thinking, wow, that's a surprise? The answer is we need to compare it to some given alpha value. So sometimes I forget my alpha. I'm going to go back up here. I'm going to write alpha is 0.05. So our alpha value is the threshold from which we need to compare our p-value. And now we're going to say, because our p-value is less than alpha, 0.05, and I wrote the alpha again, I wrote it up here, okay? I didn't write it when initially. I often forget, and then I write it at the end when I make my conclusion, because part of your conclusion is comparing to your alpha value. All right, so again, because our p-value is greater than alpha, 0.2676 is greater than 0.05, we will fail to reject the null hypothesis and find insufficient evidence to suggest that the true proportion of boxes containing vouchers is less than 0.2. Now I'll write that down. I'll pause the video here and write this down and pop it up. So our conclusion, because our p-value 0.2676 is greater than alpha, 0.05, we fail to reject H naught and find insufficient evidence to suggest that the true proportion of boxes with vouchers is less than 0.2. Now, whenever you're writing your conclusions, we are going 0.2676. We found our p-value as 0.2676. We always say we either reject or fail to reject. If p-value is greater than alpha, we fail to reject. If it's less than alpha, we reject. Okay? And then we mention the alternative hypothesis in context. There is evidence to suggest if we reject, there is insufficient evidence to suggest the alternative hypothesis. And this is always you want to write this in context. And that's it. That's your 2005 number 4. Have a nice day. Take care now. Smiley face. Happy. Bye.